Hello, can you hear me? Hello, can you hear me?
Yes, we can hear you.
Yes, Professor, we hear you.
Yes.
Okay, who has the name? There's somebody with the name Sweetheart. Is that person? Is that you, man? Is that you? Sweetheart.
Oh, sweetheart.
I'm trying to check the attendance. I'm seeing the name.
Oh, I want to type my attendance in the chat box. It's ANN. That's our first.
No, I'm talking about who has the name Sweetheart.
Ann.
Is that you?
Ann.
What's your real name?
ANN.
Okay.
ANN. That's our first name, and the last name is LOGOSE.
Oh, I see it. Okay. So Lagos, that's Sweetheart, right? Lagos, right?
Yes, sir.
Okay, I just want to make sure I got everybody's name. Brain iPhone. Okay, I got this one. 1, 2, 3, 4, 5, 6. I have how many PS? I have PS. That's PS. 1, 2, 3, 4, 5, 6. We get 7. 1, 2, 3, 4.
You got me, Professor?
What's her name?
Smith, Latasha Smith.
Yeah, I got you.
Okay.
I'm looking for the person that made it 7 person. I have walls. I got walls. But I don't got walls. Okay, walls.
You got
All right,
Taylor.
let's start. Huh? Taylor?
You got Taylor. Kelly.
You mean Tyler? This is Tyler. Tiesha, right?
Huh?
You said Tyler, right? Last name is Tyler, right?
No, last name is Kelly.
Oh, Kelly.
So, Professor, do you have Nicole
Yeah,
White?
I got Kelly here. Yes.
Oh, okay.
Professor, do you have Nicole White?
White.
Yes.
Nicole. Yeah, I got you, Nicole.
All right, thank you.
I think I got everybody here now. All right, let's continue. Now, before we left, we did an example on expectation. And before that example, I explained that expectation simply statistically, we were talking about discrete probability distribution. As the word expectation means the theoretical average of the random variable. And this is the formula for that. So we did this example. We finished it. And then this is the next example when applied to business. Okay. Let's try this example now.
So you're gonna post this, right?
You mean the handout like I always do, right? Yes, of course.
Yeah.
That's why I'm saving it.
And the video.
Okay.
Yeah, you want the video? The video, you go to Google, type my full name, and choose video, or you go to YouTube, type any of the topic we covered, put my name there, the video will pop up. Okay. You'll see the videos of all the lectures I have in YouTube. Choose the one you like. Okay.
Okay.
Now, best way actually is YouTube. Google or YouTube. If you click on Google, type my name, you see my videos. Click on videos, my videos.
So shall we see this specific one?
Huh?
Shall we see the specific video, the one that we are doing today?
Like now, the one we're doing now is tonight is probability distributions. Type it and then type my name in YouTube. It will bring it up. Okay.
Okay.
Now, it's a Sky Resort reports losses of $70,000 per season when it does not snow. I mean, if they didn't have any snow, they lose $70,000. and makes $250,000 profit when it snows a lot. So so when it doesn't snow very much, they lose this $70,000. But when it snows a lot, which is a good season for them, they make $250,000. The probability that it will snow at least 75 inches, which is good for them, that is 40%. They can get it from the local weather forecasts. Find the expectation for profit. So the first thing is if they win, gain. To gain, you have to snow a lot. So the gain will be $250,000, right?
Mm-hmm.
And the probability of that is 40%, which is 0.4. Okay. Now, if it doesn't snow a lot, they lose 70,000. That will be negative 70,000. And the probability for that is, you say 60%, 100% minus 40% is 60%, right or wrong? Am I right?
You're right. Yeah, you're right.
Who this? Yep. Okay. All right. Somebody's coming in. Okay. So that is 0.6. Okay. Now we can get our total. So $250,000, 250,000 times 0.4. We can get it from a calculator. Where's my calculator at? What is it? What is it? Where is it? Okay, I think I opened so many pages. That's why I'm having this. Okay, I'm gonna close some of them so I can see my calculator. All right. Let's see. I think this is go open it right here. It's gonna be somewhere. Okay. It just disappeared. All right, I'm gonna use this calculator. Let me close this. Close some pages. Okay. Maybe this one as well. Okay, I'm gonna close this. Now I can share it. To show it will show. It's still not showing. Okay. Where is my calculator at? All right, I'll find it again. I'll find it.
Well, why are you trying to find it? How'd you get 0.60
Huh?
for the you got the negative 70 and then you got the 0.60. How did you get that 60?
60%.
So you get what?
60%.
Oh, because it was already 40% for the
Yeah.
250, and you're doing it 100%, correct?
Yeah. Yes.
So 60% is okay. I got you. All right. I just wanted to make sure I was getting it right.
Can you see the calculator now? Can you see the calculator?
Yes.
Okay, that's good. So we have says 250,000 times 0.4. So we have it on a calculator. 250,000 times 0.4 give us 100,000, right? So we go there and type it in. 100,000. And this one is negative 70 times 0.6. So following that same process, you can multiply it. You're gonna get negative 42,000. You can double check it with your calculator. And when you add this together, you got 100,000, 100,000 plus negative 42,000. Okay, that gives 58,000, which is a positive answer, which means that they'll make a profit. 58,000, right?
Yeah.
$58,000, which is positive, and that would be a profit. It would be a profit, so it would be a good business.
Mhm.
So that the expected value, which is x times ps, I mean sum of x times ps is 58,000. 58,000. I'm gonna make it bigger. Okay, I'll make it bigger. Okay, that's making it, that means a profit. So you gotta be a profitable business. So the question say find the expectation for profit. That's our expectation right there. So it means sum of s times ps, which means this plus that. It's a good business. Any question? Any question? Okay.
No.
Yeah.
All right. Good. Excellent. Now that we have now covered general background on discrete probability distribution. Now let's look at the individual distributions under this category. You have first one, we're looking at the one we're looking at, like I explained in the class, will be binomial distribution. Now binomial distribution, let's start with the binomial experiment. Now many probability problems we have in real life usually result to two outcomes, only two outcomes, or outcomes that can be reduced to two outcomes. Example, when you toss a coin, it will land either head or tail. Two outcomes. In a basketball game, even though they have all these point, 50 points, 30 points, the result is either they win or they lose. Again, two outcomes. When a baby is born, it's either a male or a female. Two outcomes. Blood pressure, whether it's 120, 140, 170, whatever it is, either it is normal or it is not normal. So, right? Again, two outcomes. So this kind of scenario are examples of binomial experiments. Okay. Now, the features of a binomial experiment, like I explained, it starts with having an outcome that is reduced to two. See, a binomial experiment is a probability experiment that satisfies these properties. One is that each trial have only two outcomes, or outcomes that can be reduced to two. B, there must be a fixed number of trials. C, the outcome of each trial must be independent. Okay, 3, the probability of success must be the same. Okay, so, and when all these properties are together, so the outcome of all the binomial experiments multiplied by their probabilities will give us the binomial distribution. The outcome of a binomial experiment and their corresponding probabilities will give us the binomial distribution. At this point, we need to look at some of the terms we use in calculating binomial probabilities. Those terms are small p, means the probability of success. Now, when we think of success here, it doesn't have to be in the positive side. It depends on what you are looking for. If you are looking for probability of those that fail, then your success will be probability of those that fail. Okay. Q is probability of failure, which is we always get with this formula, 1 minus p. Because once you get your p, 1 minus p will give us your q. N is number of trials. X is number of success in n trials. So all this, put them together into a formula for binomial distribution, which is that the probability of x equals n combination x. Remember, we did this last night. I showed you how to get it last night. any combination x times p to the power x times q to the power n minus x. So that is the formula we use for calculating the binomial probabilities. Now, it might look like a monster, but when we start using it, you see that it's simple actually. Let's look at a few examples. Progress exercise. Look at this. It says, find the probability that in 5 tosses of a fake dice, a 3 appears at no time. Excuse me. At no time, B once, C twice, D 3 times, and E 4 times. Remember that the formula that we have, remember, is for formula applied for x equals 0, 1, 2, 3, all the way to the last n. And that's the formula we need to find these probabilities. Okay. The first one is part A. You have to identify the P, Q, N, X. So you can have N equals P equals, all this should be small letters. I don't know why it's changing to upper letters. Okay, P equals, then Q equals, then X. Then we can be able to plug it into the formula. Remember that the formula is this is why, I don't know why it's giving us all this number. You can put it right here. Solution, have solution right here. Solution. Okay. And is that. Now let's look at let's revisit our question. Let us revisit our question. Question says, find the probability that in 5 tosses, how many times was the dice tossed? How many times?
5.
How many 5, right?
Yes.
So n is 5. It's tossed 5 times. P, for a dice, like I explained last night, on the Monday when we are doing probability. For dice, probability of any outcome is 1 over 6. Because a dice has 6 sides, right?
Yes.
Right or wrong?
Right.
So 1 out of 6 means 1 divided by 6. 1 divided by 6. 0.167. 0.167. 0.167. And Q, like I told you here, Q is always 1 minus P. So our Q will be equals 1 minus P, and our P is 0.167, 1 minus 0.167. Okay. Equals, so 1 minus 0.167. We got 1 minus 0.167, 0.833. So you have 0.833 here, 0.833. Now this will, if you remember, this will be the same for all our calculations here. So the first question says, at no time, that means 0 time. So our x is 0. Now we can plug all of this into the formula. So probability of, anywhere you see n, you put 5. Anywhere you see p, you put 0.167. I mean in the formula. Anywhere you see q in the formula, put 0.833. and anywhere you see x, excuse me, let's say this now. See x, put 0, so that we have get my pen. Okay, plugging all this into this formula here. I think I'm going to move this down a little bit so we can have more room. Put it down so you can have more room. Okay, good. Plugging all this information into the formula. Whoa. It's something. Okay, I have to move it back because it has all these spaces. Okay, plugging it all back, we have that probability of 0. As for x, you have 0. So probability of 0 will now becomes equal. I'll make it big so you can see it properly. It becomes n. For n we have 5. So have 5 combination x is 0 times, okay, times, now 5 combination 0, we're looking at this 5 combination 0, okay, times for p, our p is 0.167, so have 0.167. It says raised to the power x. Now x is 0. Raised to the power 0 times, okay, times q. Q is 0.833. Put 0.833 raised to the power n minus x, and our n is 5, and our x is 0. So it's 5 minus 0. Minus 0 equals. So I'm gonna put it as an exponent. Okay. So with this, we can put this in the calculator. Let me write them down on my paper. 5 combination 0 times 0.167 raised to the power 0 times 0.833 raised to the power 5 minus 0. Now, let's put this in the calculator and get our answer. Okay? All right. Taking you there so that we have, okay, see MPR, the one we did last night. Okay, 5 combination 0, 5 comma 0, okay, then times 0.167 raised to the power 0, excuse me, raised to the power 0, okay, times 0.833 raised to the power 5 minus 0. 5 minus 0 is 0, right? 5 minus 0 is 5. Am I right or wrong?
Yeah.
So that means,
Right.
yeah, so that means answer becomes 0.401, 4011, okay, 0.4011.
Man, don't move that yet. Don't move that yet. Let me make a copy of that real quick.
It will be on the handout.
Oh no, I'm talking about how you put it in the computer.
Calculator.
I mean,
oh, okay.
on the computer. Okay, I got it. Thank you.
You're welcome. So you can see right here 0.4011. See? So the probability that it appears at no time is 0.4011. See? Questions? Excellent. Now, second one says the probability that it appears B part say only once. In that case, our X is 1. So our N is still 5. Our P is still 1.67. Our Q is still 8. The only thing that changed is X, because it says appear once. So in that case, part B, B part, when for X, it says appear once, right? That's the only thing that changed. So I'm going to bring this down. They all remain the same except the X. Okay. So X1, why is X1? Because it says the probability that in 5 tosses of a fair dice, a 3 appears once. Once means 1. Okay. So our S is 1 this time. So we apply the same thing that we have here. Probability of 1 becomes, let me make this big. Make it 18. Yeah. Becomes equals 5 combination 1 times. I'm gonna go back and make this. Okay. All right. 5 combination 1 times. Why is not make it 20 then? Okay, times 0.167. Remember the formula. Formula is right here. See? So 0.167, 0.167 raised to the power 1 times, okay, times, change this to raised to the power 1, okay, times 0.833, 0.833 raised to the power 5 minus 1, because the formula says n minus x. So 5 minus 1. Okay. 5 minus 1. So I'm gonna change this. Okay. Now we go and plug this in the calculator again to get our answer for that one. So let me write it down. 5 combination 1 times 0.167 to the power 1 times 0.833, 5 minus 1. So going to my calculator, I'll put this in. It's already there. So all I gotta do is to change the X part to 1, right? 1.
Yes.
Change this to 1. 1. And 5 minus 1 is 4, right? Am I right?
Yeah.
And that gives us 0.40220. 0.4020. Okay. All right. So we have 0.4020. 0.4020. See?
Yes.
So that answer part B. Part C says, twice. A 3 appeared twice. So our S is 3. I mean, is 2. So everything remains the same. Excuse me. Let's see. Okay, stop this mumbling. Okay. See, I said that this time is 2 here. Twice. So that the probability of 2, okay, twice becomes 5 combination 2, 5 combination 2, okay, times, check this to regular. Oh, excuse me, I messed it up. Okay, then 5. Okay, this one. Okay, times. We got 0.167 raised to the power 2 times Okay, 2 then times 833, which is here 0.833 raised to the power n minus s. According to n, that means n is 5. 5 minus s, that's 5 minus 2. Okay, yeah, make it okay. Now let's go and put this on the calculator. Write it down. 5.2 times 0.167 raised to the power 2 times 0.833 raised to the power 5 minus 2. Okay. Going to our calculator, we have it again. 5 comma 2 this time. Okay. Times, okay, 0.167 raised to the power 2, okay, times 0.833 raised to the power 5 minus 2 is 3. Am I right?
Yeah.
3. Give it 0.1612. 0.1612. So we're gonna put it point 0.1612. So that's basically what it is. I did part A, B, and C. You might try as a practice at home. You can try it as a practice and can show me in the class. Part D and part E. So that our next session, we have our final session will be have a final session after this one. We'll now finish up for the night. Okay, so we have one more session and we are done for this night. Okay, we have only 6 minutes, which should not be enough. So as a practice, finish part D and part E as your own practice. When we come back from break from this 10 minutes, we now finish this rest of this, and then we are done with discrete probability distribution. Okay, I see you soon.
You said when we come back from break?
Yeah, we have only 6 minutes left. We're not going to be able to do anything with that. So I said I did part 1, 2, 3. Try part D and part E. That's for your own practice, you know. We'll come back. We'll come back again after 10 minutes. So I'm going to time us out now, so that we can finish.
Also because the class is over
Oh.
at 8:30.
Yeah, but
So
remember,
we
this
taking
is
a break.
we're not taking a. It's not really a break because we don't have enough time to finish this. Now, remember, this class is 2.5 hours. So we have one more session.
Okay.
So I will time us
So
out
we come
now.
back when in 10 minutes?
Yeah, log back in after 10 minutes. Yes. So you can finish up. Okay.
Okay.
All right.
Okay.
All right. See you in 10 minutes. Yeah.